Alright. You guys see how this is got a recording now? Okay, so now we're recording. What I need from you, for you to be as quiet as possible. Keep up if you can. Otherwise, just watch, because we're going to stop this recording, post it to YouTube, and then we're going to pull it back up. And you can re-watch the lesson to get your notes. So, today's objective, Today's objective would actually be for the student to practice reflecting images across the X and Y axes. Javier, Juan, and Mason, I'm going to ask you three to go ahead and leave since you're incapable of being quiet. Go ahead and set out in the hallway. Not Juan, Jose. Go. Sit right there. So, normally the way this would work, start off by telling you, hey, this is what we're doing today. What we're doing today is we're going to practice reflecting images across the X and Y axis like we do every day in class. Of course, you need to go ahead and have today's date on your notes. 1/15/14. At the end of the notes, go ahead and start your line. And our vocabulary word for today is dilations. A dilation occurs when we change the object's original size. Okay? We can make it big, we can make it small. A dilation means to change in size. Now, our HOQ, the question I want you to be able to answer at the end of the day, not going to require a whole lot of thought, but I do want a good explanation. Tell me, you're going to tell me where in everyday life you see reflections, and you can use anything you want except a mirror. Where in everyday life do you see reflections? We're going to say outside of a mirror. Now, notice I left a couple spaces right there so that the HOQ answer can go right underneath it. You want to write HLQ answer like so, and then fill in, you can, or you can just continue writing from right there. Either way is acceptable. Okay? Now, the examples that we have set up on example 1 is to reflect across the y-axis. Now, when you reflect something, you create an image of it. So, we're going to go ahead and call this our original, because we are going to reflect across the y-axis. And that reflection across the y-axis creates our image. Now, we know that this H, the shape of this H, will not change, even though we reflect it. So we're going to go ahead and put the shape of our H and the location of its new points down. I'm going to draw this out nice and neat so that everybody can see. Now the question is, when we make this image, which point goes where? And how do we show these points? When you have a reflection, like a mirror reflection, it is closest to closest, farthest to farthest. What that means is A is closest to the y-axis right now. So its reflection, this point up here, will still be A. We'll call it A prime. We'll do a comma to show that it is a part of the image. Again, the D is closest on bottom, so it's going to stay closest, and we're going to call that D prime. B is going to be farthest away on the top, so that'll be our B prime. And again, C, farthest away on the bottom, C prime. So you see our original and you see our reflection, okay? We'll call our reflection our image, okay? Because when you look in a mirror, you're looking at an image of yourself. Does that help you? Does that make sense to you? Okay? So, our first one, we're reflecting across the y-axis. What I want to do is over here underneath our examples, I want to take each of our points and look at how they changed. So we've got point A, right? The original place of point A would be over 1, up 1, 2, 3. So our original place would be 1, comma, 3. Now when it's reflected and becomes A prime is negative 1, but still a positive 1, 2, 3. So A prime's value would be a negative 1, comma, 3. All right. Let's double check. Let's use one more. Let's look at B. So original B, I'm over 1, 2 spaces, and I'm up 1, 2, 3. So my coordinate would be 2, 3. B prime, I'm going to be over 1, 2, 3, or 1, 2 negative, and up 1, 2, 3. So my B prime location is actually negative 2, comma 3. Now, what you should notice, or what you should see, is the similarity in the points. What is changing from point A to A prime? What changed from point B to B prime? When you're looking at this, you should notice that A prime, my x value, because I'm rotating or reflecting across the y-axis, my x value becomes negative. We are multiplying whatever that value is by a negative 1. Same here. B to B prime. We are multiplying the original by a negative 1. Now, let's go ahead and look down on example 2. Example 2, we're going to reflect x across the x-axis. Okay? So, the y-axis, we went over. The x-axis, we're going to go down. Slide this up just a little bit so we can all see. So, it's the same thing. It's a mirror image. An x is not going to change. Okay? That same x is going to be located down at the bottom. So what I'm going to do is I'm going to go ahead and set my first point, set my second point, my middle point, my bottom, and my bottom outside. So I'm going to use a ruler, make this nice and neat for myself. You can use edge of a pencil, you could use edge of a book, anything that will give you a straight line if you want. Now again, we have to look at where the location of the points are going to be. With a reflection, closest to closest. So since we'll use D. Since D is the closest to the x-axis, its exact opposite, D prime, will be located also closest to the y-axis or to the x-axis. Now, C, again closest to the x-axis in comparison to B, is going to give me C prime here. B is going to be farther away, give us B prime. A is going to be farther away, give us A prime. So since in the first one we did A and A prime, B and B prime, in this one we're going to do D and D prime, or D and D prime, and C prime. So let's look at the point C first. C has a location of negative 1, positive 1. So our point, negative 1, comma, positive 1. Whereas C prime, we're still negative 1 on our x-axis, but negative 1 also in our y-axis. So I've got negative 1x, negative 1y. Okay, let's move on to D. D, originally I'm at negative 3, positive 1. Negative 3, positive 1. D prime. Now I'm at negative 3 and negative 1. So now we're looking at this. We're trying to think, how are they the same? How are they different? Now, in our first one, we multiplied the x value by a negative 1. In our second example, we are looking at the y values. Notice, 1 became negative 1 in both of these. We are literally multiplying our y value by negative 1 to find its image, its prime. So 1 times negative 1 gives me negative 1. Again, 1 times negative 1 gives me negative 1. Now, if this was our original, say all of our primes were our original, and we still multiplied those by negative 1, well, negative 1 times negative 1 is a positive 1. Quickly. We can go both ways, okay? But what you need to understand is that when we are reflecting across the y-axis, we are going to affect our x values. When we are reflecting across the x-axis, we're going to affect our y values. So, for your practice problem that you'll have, go down here. On your practice problem, I want you to make a 3x3 grid. Use mine 1, 2, 3, 1, 2, 3 here, and 1, 2, 3, 1, 2, 3. Okay. Go ahead and label your x and y values, our x and y axes. And what we're going to do is we're going to reflect triangles, or a triangle, across both the x-axis and the y-axis. Okay? We're going to start with a simple right-angled triangle. Actually, we'll start with an obtuse triangle. Here, we're going to call this our original. I need you to reflect across both the x and y axes. So when you're done with this, I should have a triangle in this quadrant, quadrant 1, and as well as a triangle in quadrant 3. All right.